We are returning back to our financial advisory problem, but now what we're going to use is we're going to use the annual compounding formula to see if if my future value on my money is able to be a higher amount. So just going back, I have $7,500 in my savings and I'm looking to invest into a U.S. savings bond for my son's college fund. He will be attending college in 15 years. My goal is to save $20,000 and I'm looking for the financial advisor who can make me the most money. Currently, the annual percentage rate for a U.S. savings bond is 6%. What is the future value of my money after 15 years? So since we're using the annual compounding formula, we're going to write it down here first. F equals P, the F is the future value, equals the present value or the principal, multiplied by the quantity 1 plus the rate in the form of a decimal, all raised to the t power, the amount of years. Now that's an exponent. So we're going to define our variables. The present value of my principal is 7,500. The APR is 6%. So the rate in the form of a decimal is 0.06. And the time, the t is equal to 15 years. So we're just going to input these variables into our formula. We're trying to figure out what f is. So we're going to keep f just like f for the future value. P is equal to 7,500. Parenthesis 1 plus the rate, which is 0.06, all raised to the t power, or the 15th power. Now we're going to follow the order of operations. We have a lot of stuff. We have multiplication, we got parentheses with addition, and we have exponents. So the order of operations says we have to do the parentheses first. So I'm going to just rewrite everything and just do that one parentheses operation. So this is parentheses, we have addition within the parentheses, so 1 plus 0.06 is equal to 1.06 raised to the 15th power. Now at this point I can just input this into my calculator. So we're going to look at the calculator, and the first thing we're going to input is 7,500. Then we're going to put the parenthesis, 1.06, close the parenthesis. And to get to the exponent, what we're going to do is we're going to raise that to the 15th power. So this little, triangular type looking thing is the raise to the 15th power. And then you just hit enter. And then you get the answer. The future value on our money is $17,974, and I'm going to round that 8 up to a 9 because of that 6, and 19 cents. Now remember that my goal is $20,000. I did not achieve my goal under the annual compounding formula. So what I need to do is I need to figure out, well, what does my principal, my initial money, my present value, what do I need to invest now to achieve my goal? So, using the annual compounding formula, how much money do I need to invest if my goal is to save $20,000 in 15 years with an APR of 6%? So I'm going to use the same annual compounding formula here, but now I'm trying to figure out what my principal is. It's right now 7,500 is not enough, so I'm going to have to increase that, but I need to figure out how much do I need to increase that under the annual compounding formula. So the future value is my goal, 20,000. The rate is still 0.06, and the time is t equals 15 years. So we're just going to input these variables into this formula. F is equal to 20,000. The P is what I'm trying to figure out, so I'm just going to leave that as P. Multiplied by the quantity 1 plus the rate 0.06, all raised to the t power, the 15th power. Now I'm just going to do what the order of operations states. Order of operations states that I have to do the parentheses first. So I'm going to rewrite this, 20,000 equals P multiplied by the quantity. 1 plus 0.06 is the same thing as 1.06 raised to the 15th power. Now what we're trying to do is we're trying to figure out what P is. We have to isolate P. You've got to get P by itself. So at this point, we can really go two different ways. So I'm actually going to show you both ways. I'm going to take this. This is going to be the first way. And you can pick which way you want to attack this problem, just depending on your mathematical, comfort level. And this we'll talk about this the second way. But at this it's kind of like a Y in the road. You can go two different ways. So we're going to talk about the first way. Just continuing to follow the order of operations, we have 20,000 equals P multiplied by 1.06 raised to the 15th power. So one way to solve this problem is just to figure out what 1.06 to the 15th power is. Now, when we put that into our calculator, we can go 1.06, and we're going to raise that to the 15th power and hit enter. Now we get a really, really big number, and when you're doing these types of problems, you have to write out that really, really big number, or else your answer is going to be off. So 1.06 to the 15th power is the same thing as 2.396558193. So we're just going to have to write all that out. So 1.06 raised to the 15th power is 2.396558193. Whew. Okay, is equal to 20,000. Okay, got to write it all out. So, now what we're trying to do is isolate P. Well, how is this big old long number related to P? Well, this is the same thing as P times 2.39 da 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 da. So to isolate P, to get P by itself, we have to do the inverse operation of multiplication, which would be division. So that means we have to divide it by whatever this number is. So we're going to divide this by 2.396558193. Whatever we do to this side, we have to do to this side of the equation, which would be 2.396558193. Okay, 2.39 da 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 divided by the same number is going to equal 1. 1 times P is equal to P. Therefore, we have isolated P by itself. When we go 20,000 divided by 2.396558193, we actually end up getting $8,345.30. So this is what our principal needs to be, our present value of money that we need to invest now in order to save $20,000 using the annual compounding formula is about, if I have $7,500, that's about, about $845.30 more than the amount of money I have now. So it's I'm just going to have to come up with a little bit more money in order to achieve my goal. But so let's look at a different way of solving this particular problem. So we were talking about when we got here, there's a different pathway we could take. So we have 20,000. We're going to kind of rewind a little bit. 20,000 equals P multiplied by the quantity 1.06 raised to the 15th power. And I just wrote it up here. So this is one way we can do it, or we can go up here and we're going to talk about a different way to solve this problem. So 20,000 equals P multiplied by the quantity 1.06 to the 15th power. Now, if you notice here on our calculator, I'm going to bring this back. 1.06 to the 15th power is the same thing as this big old long number, right? So 1.06 to the 15th power is the same thing as this number. This means a number. So P, and so what we have is we have 1.06 to the 15th power multiplied, that big old number multiplied by P. So one thing I can do is if I want to get P by itself, I know that P is related to this. This represents a big old long number. It's related through multiplication. So I can use the inverse operation of multiplication, which would be division, and I'm just going to divide it by 1.06 to the 15th power. Because this number, 1.06 to the 15th power is the same thing as 2.39, all that, and divided by 2.39, well, that's just the same thing as writing 1.06 to the 15th power. And whatever I do to this side, I need to do it to this side of the equation as well. Now, now at this point, 1.06 to the 15th power divided by 1.06 to the 15th power, this divided by the same thing, that's going to be 1. 1 times p is p. I have now isolated p by itself. All I need to do is input this into my calculator. So how you input 20,000 divided by 1.06 to the 15th power is first you put in the 20,000 divided by 1.06 raised to the, I'm going to use that little triangular thing, to the 15th power. I'm just going to put in 15 and then hit enter. And you end up with the same principle that our present value of money that we've determined over here. So it's just two ways to come up with the same answer. $8,345.30.